Good
I'm
afternoon, Jan.
I made it. Good afternoon.
All right, excellent.
Ooh,
Yeah, yeah. You'd
it was a rush,
mentioned that you might not be able to make it. So
mm, but just in time.
excellent, excellent.
Okay,
Well, how was your week been?
quite busy, quite busy like usual. I thought, I thought that problem with the synchronization last time was solved,
Oh no.
and it seems to be solved, unless for one person who syncs, she got different results in the database than all
Hmm.
the others. So it's okay for everybody except for one person. Then I say, okay,
Okay.
we restart the synchronization of the database, and then it was all right.
Mm-hmm.
I took a copy of the database, but yeah,
Nice. Yeah.
it's a black box. Is it related? Is it not related? But that's running now since 2007, and I
Hmm.
never had any difference uh, in the
Wow.
database.
Hmm.
Um, and now at once, yeah.
Yeah.
so
Yeah. Well,
so
this is precisely what is meant by eventual consistency. It's like, yeah,
yeah.
yeah. It's not the eventual part; it's the consistency part. And yeah, your
Mhm.
consistency was violated.
Yeah, because we could synchronize as much as we wanted, but so
Hmm.
you
Yeah.
see, reasons enough for Jinaga.
Yeah. Well, I
Uh,
hope you can do that forensics and report back what was the ultimate cause there. Um, yeah, if indeed you can peer through the black box and figure out the ultimate cause.
well, the question is, what do I do? Am I gonna spend hours and hours and days to
Hmm.
try to find out what was the problem? It might not come back anymore, or try
Yeah,
to get into Jinaga and look forward.
yeah, yeah. It would be an
Um,
academic process at this point, but yeah,
because,
doesn't keep
I,
you from
I
being
always
curious.
I always like to know what is going on.
Yeah,
Um, but yeah, not having the source code of these modules means that you're always at risk
hmm,
for a problem that you don't have under control.
yes,
So I'm just hoping that the that the next couple of months uh, it will work like it worked since 2007.
hmm,
Um, we will see.
yeah, yeah. Well,
Never panic before there is a problem.
true, true. There's plenty of time to panic after you've discovered the problem.
Mm.
Yes.
Well,
Well,
married for 25 years
yeah,
and 3 children, so
yeah,
used to problems. uh, no.
yeah, yeah. Show me one I haven't had yet. Yes. Well,
Yeah.
yeah, I've had a busy week trying to get the last little pieces to fit together for client side purge. So
Mm.
so yeah, I think I've got something working, and it passes the unit tests. And
Okay.
I've not tried it on on the actual device, well simulator, uh,
Mm.
as of yet in an actual application. So I figured, hey, why not on the stream? Let's just try it out
Mm.
and see if it works.
And if Murphy is not there, everything will work.
Yes, yes.
Mm.
And if things fall apart, hey, that's good content.
Then we add a unit test.
Yes.
Mm.
Say, oh yeah, I forgot to test that scenario. Yeah,
Mm.
that has happened many times.
Mm.
That's one of the
I'm
reasons that
curious.
it's so well as unit tested.
I'm curious. Don't keep me waiting.
Okay, yeah. Well, let's start with the Zoom. I should have gotten Zoom up and running just in case, but
Mhm.
I did not. So
I have it here. Yeah.
there we go. And multiple, just in case we want to do that. And sharing now. Okay. So let's begin with. We don't want to go full screen. There we go. Yeah, if I go full screen, then it stops streaming the video. So, all right. So, yeah, what you should be seeing now is Blog Maui in Visual Studio.
Yep.
And we've got I've gone ahead and installed some packages here for Janaga Store SQLite, Janaga Maui, and Janaga. And you can see these all have this crazy little suffix. So these are pre-release packages that I deployed to my own NuGet or GitHub package repository.
Mm-hmm.
So that's going to allow us to test out these new features and see if they work before publishing the actual NuGet repository.
And we have a visitor in Discord.
Welcome. Thanks for
Morning.
joining in. How's it going?
Really well, and yourself?
Fantastic. Have you started reading the book, The Art of Immutable Architecture?
Yes, I finished it
a
few months ago.
Excellent. Have you been able to put any of the ideas into practice so far?
Yes, so I was with you a few weeks ago.
Oh, okay. Sorry, I didn't. Oh, yes.
No.
Welcome back, Cabbage. Yes. Switch back
Thank
to
you. Yeah, no worries. I've started, as I mentioned, I built the sort of draft application to see how all the models would interplay in your Janaga JS framework. And I've started writing what I'm hoping will be something that will suit my needs in Rust. Rust doesn't have native immutability. It has to be like library based or just, scoped to the particular module as it is. But it's been slow going, so nothing too crazy to report.
Okay. Yeah, I am curious how that is going to play out. But yeah, the lack of native support, actually, I've not found with Janaga JS, JavaScript doesn't natively support immutability, but I haven't found that to really be an issue because if you wrote your application to change the facts that it received, nothing would happen. Maybe you would mess up your React state, but no. Even then, yeah. By the time it gets into the React projection, if you're using use specification, it's disconnected from the original facts. So yeah, you probably just wouldn't write any code to modify them.
Yeah, that makes sense.
I think it'd be fine.
I'd hope that if you're using a library such as Janaga, that you won't be modifying your models. So.
Yeah. Like if you're using Reacts with Redux or MobX state tree, you're not going to modify your state. Just by assigning to the properties, you're going to use the actions in order to publish states into or publish changes into the machine. I mean, you've already made that choice. Yeah, and that's what's going to work. So, yeah, I think that'll be fine. Yeah, it's kind of convenient that .NET now does support immutability out of the box and enforces it, but that ultimately just ends up making the code more concise. That enforcement doesn't really play a role in the day-to-day operation. So I think you'll be good.
Yeah, and like I say in Rust, if I say in the library, like you define your facts here and you define your queries or your facts generation somewhere else, and you can use the module privacy rules to have just setters or just getters and no setters, and it's an equivalent, but not quite. read-only.
Mm-hmm. Well, excellent. So yeah, I will go ahead and do a share screen on Discord as well, so that you can see what we are going to be talking about here. And then, yeah, let's dive into this new feature that I've been implementing both on the JavaScript side and now on the .NET side, to be able to purge information from a database. So, all right. So we've got our pre-release packages installed so that we can try out the feature. And if I go ahead and run this on the simulator, then, whoa, big simulator comes up. Bring that down to something reasonable. So what I've also added to help out with this test is this nice big exception. What is this? The VM is not suspended. I don't know what that means.
The simulator is gone.
Yeah. Let's try that one more time.
Or is he hidden behind there? No? Yeah.
Yeah, I know that we have used the simulator on the stream before, so yeah, comes up. It's good. All right. It might have been the live preview was trying to connect to it. So yeah, I've been using this to help figure out some XAML stuff. It's kind of a cool feature in Visual Studio. Yeah, so I've added a couple of features to Blog Maui in order to test things out. The first thing is from the account page. You'll notice this new button here called Purge that calls the Purge endpoint on Janaga.net. We also have export facts. So export facts is going to call the export function, give us all of the factual from the local database, and just dump it to the screen. And so you can see here that we've got various sites. So here's the blog site. We have it F3. The F4 gives it a name, QED code, and then we got another site. Then we get down to lots of sites, but a lot of them have been deleted because I've been testing up all sorts of features through the notebook. Finally, though, we will get down to some posts. So here's a post in site F3, title being Degrees of Freedom. So if I were to navigate to, let's go back home and navigate to the site QED code, we'll see here is, I've probably renamed that post a few times, but we've got the posts in there. And then finally, another feature that's going to help us out is on the edit screen. I added this big red delete button. So this will create a delete fact. The ones that you've already seen in that export, I created those through a notebook. Now you have the ability to delete right on the mobile app. So putting all these features together, I should be able to demonstrate purge conditions and how they how they work. So for example, let's go ahead and take this QED code site and let's hit the delete button. So nothing happened. It's still here. Let's go back to posts. Okay, it's removed here, so I can't navigate to it anymore. Why did that happen? Let's take a look at the site list view model. So this is going to be sites, site list page, site list view model. And I don't need a live preview anymore. So in here I've got, I want the sites, so facts of type site. I'm not using the Floyd syntax yet, but I've got where it's related to the site relator, and there are not any site deleted. But I only take the site deleted where there are not any site restored. So that means by creating the site deleted fact, I was able to exclude it from this specification. But of course, the fact still exists. I just created a brand new fact called site deleted. And if I had the appropriate feature on the mobile application, I could look at, I could have a specification that gave me all of the site deleted facts, and I could call that a recycle bin and say, okay, let's go ahead and select one and hit restore. It creates a site restored fact and brings it back. So that's just patterns. So far, that's not purge. Now, let's see what would happen. And in fact, I can go ahead and use this new feature here, export facts, so that we can prove that, F3 was the blog. There's the blog site name, QED code. And if I scroll all the way to the bottom, here is, oh wow, F100. Blog site delete. Oh, that was F69. That was a completely different site. So, yeah, we can see here's F69 is still there. It's got the name, QED code, change the name to historical modeling, change the name to immutable architecture. No, these are not site name changes. At some point I changed the name. But then we've got posts that will end up in F69. Yeah, like here's a post. And we call that 4 theorems that every developer should know. Yep. So, proving that data still exists on the local database. Now, if I could prove that this mobile application will never look at that data, then I should be able to remove it from the local database. That's the whole idea behind Purge. But I have to be able to prove it, and that Purge has to be done in a way that maintains eventual consistency. I can't purge it in such a way that something happens on another machine and then it pops up again. I can't do the whole active sync. I can't do that kind of thing. So let's set up a purge condition and see this work. So I am going to go to Janaga config, and in here I am creating my Janaga client. So I call Janaga SQLite.create, and if I have done everything correctly, I haven't even tested that I can do this through Janaga SQLite client, but I think I did all this correctly, so I should be able to set up purge conditions. Yes, good. So that is going to be a function. It has no idea what the function should look like, so yeah, Copilot is giving me crazy stuff. But this is a function that takes a purge conditions and returns a purge conditions. So it could be that. Yeah, that is the identity that means no purge conditions. But I could also say dot, and then I've got a couple of options here. I'll demonstrate the purge option here. So purge, what do I want to purge? I want to purge sites. And then when do I want to purge them? When exists a site deleted. What site deleted are we talking about? Deleted. Not not delegate, deleted dot site. There we go. So whenever there exists a site deleted for that specific site, then that site can be purged. So that's how we set up the purge condition. There are a few other options here that that we can use to kind of make things even more interesting. There's .when exists, and that allows you to just give an entire specification. So it's a bit more wordy, but it gives you a bit more power. For most of your purge rules, purge conditions, it's just going to be purge this when that exists, when a successor exists. So I was able to condense it. And then there is the with function, which takes another function of purge condition to purge condition. So that lets you chain these together. You can define purge conditions for each of your different models, and then use with to combine them all together. So for right now, we'll just have this one purge condition. So let's go ahead and run it now with this purge condition, and we should see some of the some of the checks and balances come into play in the form of exceptions. Okay. So up it comes. It should take us immediately to the sites list where we'll see our first exception. Boom. Here we are. Perfect. Invalid operation exception. The match for blog site is missing purge conditions. So there should be a condition where not exists for a particular blog site, the deleted, blog site deleted. So we have to have that purge condition on every specification that uses the type blog site. If we take a closer look at this specification here, we can see that, okay, well, this is the watch. Let's look at the specification that it's using. Yeah, so here's the specification that we were just looking at, where there are no facts of site type deleted. Okay, that part is good, but then there's this extra and not exist site restored. So this is telling us I have to have exactly this condition. I can't have any other conditions attached to it. So if you think about it, you can kind of see why that is the case. If I were to delete a site, that would be enough, according to this purge condition, to go ahead and purge the blog site. However, if I then later come back and restore it, all that data is gone. So so now the fact that a purge happened becomes visible, and these checks are there to ensure that the fact that it's purging has no effect on the behavior of the application. It should not be visible. So instead, now to fix that, I need to get rid of this. So now I just list all the sites that are not deleted, and I've taken away the ability to restore. I've taken away that recycle bin capability. So let's restart that, and it should run. Now, of course, if this were your actual model, and you said, but I want that ability to restore, well then you would really want to think about how should the recycle bin really work. You should be able to look at all the deleted sites. You should be able to hit restore on those, or you should be able to say empty recycle bin, and then empty recycle bin records another fact. and then that other fact is the purge condition. So, so that one can't be undone. There is no where not exists attached to that condition, and that's what you would set up. But here, I just used the existing site deleted to do the demo. So it's now able to run the specification. Everything is looking good. I'm not certain why it's yellow, but we're going to continue to go with it. Yeah, probably my authentication is timed out. I haven't re-logged into this this application, and it's probably been over 90 days since I last ran it in the simulator. So that might be the reason for that. But as you can see, it's local first. Everything runs off the local device. Okay, so now that we have the purge condition, you might expect that when I export the facts, I would not see fact number 69. Let's go ahead and get down there. And wait a minute, I still see the blog site. Why is that? I still see the name, QED code. Why is that? And then I also still see here's the domain, and here is, there's going to be a post as well. Yeah, there we go. There's our first post. There, 4 theorems every developer should know. So why do I still see these things? Well, it's because the purge condition is true, but it didn't just become true. I still have the blog site deleted fact here. That fact was recorded before I wrote the purge condition. So it doesn't know to trigger the purge. And that is what the purge function is for. So now let's go ahead and cross our fingers, test this feature. I should be able to hit the purge button. It doesn't give me any feedback because it just calls a function. But now when I export the facts, I should see something different. I will still see F69. Yeah, I still see the blog site, but notice I no longer see any successors of F69. So we're seeing 67, 65, 81. So we are not seeing any titles or domains or posts or anything related to F69 except for blog site deleted, which is now number 94 because we moved things up. We deleted some facts before we got to that index. So so we can't get rid of the site itself because that would violate eventual consistency. If somebody told us about that site, we would have no recollection of it. We would think that it exists. It would pop back up. We can't get rid of the blog site deleted because that was the trigger. That's the tombstone. I have to remember that it was deleted. So we keep the purge root, we keep the trigger, and we keep anything that's in between. So all of the predecessors of the trigger so that it makes sense. But we delete all the other successors. And so yeah, the purge is working on the local device. That's pretty cool. First time I saw it. It just passed unit tests before this. Woohoo! Thank you, Cabbage. We're going to have you back every week.
Add some energy.
I love it. Okay. So yeah, with that one, we saw that the that we had to run the purge function. We shouldn't have to have the user purge their database manually, or even have some timer that's running that purges periodically. We should purge things as soon as they're purgeable. So to that end, we've got this this post called the feed algorithm. It's in site 72. If I find site 72, there it is. Its name started as immutable architecture. Did it change? Yeah. Wait, no, there's the domain immutablearchitecture.com. No, okay. So let's go ahead and delete 72 and see if we can get rid of this post, the feed algorithm. So let's come back to home. Here's immutable architecture. And we've got the feed algorithm. And another post. Let's edit and delete. Now that we created that site deleted fact with the purge condition in place, it should have run the purge in real time. So I'm not going to hit the button. I'll just export the facts. Let's scroll all the way down. And so here is the site 72. We can see there is nothing related to site 72 except for blog site deleted. So it ran the purge in real time. Hey, excellent. So that is the purge working in Janaga.net. Yeah, I say that's a successful test, and let's ship it. So first of all, configure purge condition. Boom. I'll come back later and I'll change the purge condition so that things can be restored. And then, if you've changed the purge condition, you've already done the purge. Well, then, yeah, you've made a change to the rules, and things are not going to be consistent. But can't do anything about that. But yeah, I'll come back and I'll change this model. I think the way that I'll change the model is I will have a new fact type called blog. Oops, I put it in quotes. Blog site purged. And this will be public record site purged. And its predecessor will be site deleted. So you can only purge something after you've deleted it. So you delete it, it goes into the recycle bin, you go to the recycle bin, you hit purge. And then it takes all of the blog site deleted facts that put them in there in the first place, and it creates a new site purged for each one of them. So given that, we should be able to say when site purged, and say purged, arrow purged, deleted site. And there we go. Oh, and it's purple because it's running and it says, hey, I can't autoplay this. So yeah, that's the purge condition that I actually want to put in place. And so I'll make all the appropriate changes to make that work. Yeah, one of those changes will be to actually put the recycle bin into the mobile app. We'll try that out. That'll be good. And that will really show things off. All right. Well, that's not what I want to do. Stop. There we are. Wow, a demo worked.
We have a rule in my stand-up at my job. It's kind of a stand-up bingo where one of the demos will definitely fail.
Yeah, there are plenty of examples of failed demos on this channel. So I think the number of demos that just work like that, very few. But yeah, my colleague at Improving will be very happy to be able to deploy that feature. So that combined with another feature don't know if I've talked about, but there's a feature where you can get a local Janaga client from your connected Janaga client. So if you do Janaga client.local, now if you do a .fact, it'll just go to the local database. It won't even try to push it. So he uses that feature in order to make sure that while somebody is collecting an order on their iPad, that it just stores the order locally. This particular client doesn't want to be able to pick up a different iPad and continue the order from there. So they don't want syncing. They want to tightly control what data is on each device. So he's using .local in order to do that. Then when you submit the order, it's creating a successor to the order and captures with its predecessors all the information about the order, and it records that one with the regular Janaga client. So that one gets pushed, and all of its predecessors go with it. So that actually publishes the order, and so at that point, it's now in the replicator, and then the server can pick it up and do things with it. But the client really wants to, at that point, purge it from the local client. So now he could write a purge rule, which is really a mind-bending rule, that I'm going to purge an order when it's submitted. And then at that point, hit the button, and it'll go ahead and purge it. I do need to make sure this is one thing I need to make sure of. The outbound queue. I think it's using a foreign key to the fact table, and so if that's the case, when I delete from the fact table, I would delete it from the outbound queue, and and so in his situation, that would do exactly the wrong thing. It's like, I purge it, the facts are gone, they're not in the queue anymore, it's just gone. So yeah, before I publish this, before I make it a real thing, I will make sure that the queue survives purge. I'll just do that by copying all of the data into the queue, and then the queue gets deleted as it gets served. Nice and easy. We're not hearing you. Are you muted? Yeah, still not hearing you.
Can't hear you either, so it must be your side issue.
You hearing me now?
Yes.
Okay. No, I was mixing up the audio on Zoom and the audio on Discord. What I said, now that we have an export for facts, why not also have an import?
That is
that
on
might
the backlog, yes.
Because that might be interesting for testing, just to do experiments.
Yes, it'll also be really helpful for backup. So, you're testing out your purge conditions, and you're like, I'm actually going to be deleting data now. I should probably export backup. So yeah, you kind of have an import right now for Postgres. So if you stand up a replicator, then you can post that text file that we were just looking at in Factual. You can post that to the write endpoint, and it will write all those to the replicator. Problem is, they will be written under the under the context of the logged in user. So if you call write with an authentication header, it's going to be, okay, that's going to be the user that has written all these facts. So that user would have to be authorized for all those facts. So in order to solve that, what I also want to do is add the digital signatures to the export. So So then
Yeah.
you'd be able to import with the digital signature, and it would still be associated with the user that originally created those facts, and you wouldn't have to authenticate that user.
And then it's a perfect backup restore
Yep.
feature.
Yep. Yeah, and those signatures are shared with the local client. So so even if you backed up from the local client and somebody else had done this, but you're looking at their facts, restoring them would still associate them with that other user that you can't log in as. So so yeah, that's those changes are on the backlog. They were not immediately necessary for for my colleague to do what he needs to do. He said, "Well, I'll just back up the Postgres database." He's using the npm package, so so yeah, he's managing the Postgres database himself anyway. So like, I'll back that up, and then we'll try this out. If something happens, I can restore. Hey, it's all good.
Mm-hmm.
So I'm excited about this feature.
Yeah, the
Now we
purge
can.
features. When I told one of my colleagues about mutable architecture, his first question was, "What about GDPR?"
Yeah.
And I was
That is always the first or the second question. If it's the second question, the first one was, well, doesn't that mean that your database is going to keep growing? So the answer to both of those questions is purge.
Oh, I have a question.
Yeah.
That's kind of stemming off of Purge. So one of the possible future implications of the project I'm working on is that it will have a large accessible database that doesn't require authentication. Something similar to like Wikipedia. And I guess my question is, given this large Wikipedia style article, how do you have your consumers consume like a subslice of it, or even go offline with a subslice of it without necessarily having to download all 35 gigabytes of Wikipedia, you know?
Yeah. That is a good one. So in that scenario, I would explore a few different options. So one of the options is you already mentioned that the users don't have to be authenticated; they can just visit the site. If that weren't true, this option would work. That when a user who you authenticate and can tell them apart from other users, when they visit the site, they would have a user fact that represents them, and then you could create a successor whenever they open an article or show interest in an article that says, okay, this user likes this article. That would cause that article to be downloaded because you would have a specification that joins through it, and then you would be offline and you can see these are all the articles that you visited. And you can see your own history and you could go back to them because they'd all be cached. But that does require that you know who the user is. You can kind of fake that by doing a fake user just based on a cookie. So you visit the site, there's no cookie. Oh, okay, I'm going to create one, and then I'm going to authenticate you using this mechanism that is just, here's my cookie, and then it says, okay, there's the user that represents you. So you can kind of get there. That's probably not the best option in this scenario. Another option that I could think of would be that you'll have this workflow for editing all these Wikipedia articles, and so you're going to have lots of different facts that represent the edit, and then at some point you're going to publish a version of the article. So you might think, okay, for the public side, I'm going to have a specification that looks for the published fact, and then I'm going to assemble the article. But that is going to bring with it all of the predecessors, so all of the edits that occurred before that publication, which might not, it might be a security concern in your case, because it might be that somebody put some information in and then somebody else removed that information. Like, no, we can't publish it like this. Okay, let's publish the one with it removed. Well, it's still in the history, so it's still there. So in that case, I would define a model that has two different graphs. So you've got the edit graph, but then when you publish, it actually makes a new fact out of the projection of that publication on this other graph. And so that could just be here's the article with the text all in one fact, so it's an immutable snapshot of that article. And now that's in a different graph, so this one's no longer part of the successor chain, or predecessor chain. So now you can download those articles without seeing the history. So that just by itself doesn't solve your ultimate problem, which is how do I download the articles that this user is interested in without downloading all of the published articles. What I think I'm kind of driving toward is option 3, where you actually do that off the model. So the Janaga model is really good for workflow. It's really good for collaboration. It's not as good for large content. So first of all, you like search. You wouldn't want to execute your search on the historical model. You would want to take a projection of the historical model, put that into a search index, and then search from that. That's I'm assuming that if you're offline, you can't search the whole thing. You can search just the subset that you've read, perhaps. So that would be you would already be taking offline or off model projections for search. You could do something similar for caching the articles. Let's suppose that these weren't just articles, but they were images. Maybe these articles contain images. So you've got a large binary object. You don't want to shove that into a JSON object and then put that into a fact. That would be too big. So instead, what you would do is you would put that large binary object into a repository using something like content addressed storage. So you compute the hash of the image, let's just say, and then that hash becomes the ID. And so now you've got this this database that is ID to object, and you can just look it up by hash. So now that repository is immutable, because if you were to change the image, you would get a different hash. So you can do the same thing with text. No reason not to, even though text is smaller, but it's still a full article might be more than you want to put into a JSON object, into a single fact. So yeah, I would probably go ahead and create a content address storage a repository that you use for that purpose. Now you're using your Janaga historical model to just exchange these hashes. So yeah, if I express interest in an article, now I've got a fact that has that hash, and then I can go to this other thing and I can pull that in. So now you've got the capability to take the full Wikipedia as a key value store online, and then also have a key value store locally. So every article that you have seen while you were online and were able to fetch is stored locally. And now when you're using your local version of your historical model, those hashes still get you to the article. So it's a hybrid approach.
Okay. So my vision for my app is kind of like Wikipedia, but it will have like distributed, like a non-centralized condition where you have some guy with a phone who's like maybe mapped out the laws of Belgium or whatever, and he can go up to his other colleague with a phone. They can do a sync process, and now they both have the laws of Belgium.
And in that way, I'm hoping to kind of allow like, knowledge propagation without having to have some sort of centralized place where information moves.
Mm-hmm.
The trouble with that being, if it's a public model, then I'd kind of have to use some sort of like interest showing mechanism like you're talking about,
Mm-hmm.
because it may not have like my phone only has 80 gigs of space,
Yeah.
right? Like, and while that's definitely big enough to hold Wikipedia, it certainly isn't big enough to hold Wikimedia.
Yeah. Exactly.
So that's kind of like this mental structure that I'm wrestling with, is like this kind of decentralized knowledge sharing base based on just like clients syncing up with each other.
Mm-hmm. Yeah. Yeah. So I think I think by putting together some different patterns, you can get there. So yeah, that I definitely think that the the key value content address storage solution is part of part of the full suite. And I think that for that use case, you would want some kind of pseudonymous identity. So you might even want to go so far as have the application not log in, but instead create a key pair for me. So I want to create an identity just on the fly. It has no information about me. It's just I've created a public-private key pair, and now I'm my janaga.userfact is that public key. And so everybody knows about that public key, but they don't have any idea where it came from. And so now you can express interest by associating things with that user, and you can even if your use case includes things like this, like have some sort of an editing capability where you want to keep track of, like maybe it's Wikipedia, but it's not just a download and cache, but also I can make edits while I'm offline, and I can just share those edits directly with other people, and then those edits can propagate, maybe something like that. So so then you would want to authorize those edits according to some core group of authors or authors related to this 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 domain or this article, whatever your model, whatever your domain requires. And so you build those authorization rules in. Everybody's running the same authorization rules, so now they can use the public key that you've shared to say, okay, that's the user, and then there are other parts of the model that say, this user is part of this group, so therefore I authorize them. And then as you're sharing facts around, it also shares the signatures, so they verify, and I know that user authored this particular fact. And so you can be pseudonymous, keep all of the private keys local to the device, and still be secure that way.
That's interesting, for sure. And I think it makes less sense in my model to have an editing capacity that's not tied to an identifiable individual,
Mm-hmm.
but certainly a consuming capacity, which then pseudonymous pairs would allow that functionality.
Yeah, certainly there would be one fact that would be authorized to that particular user, and that would be that they're interested in this article. So you couldn't just spam by somebody by getting their public key and saying, oh, you're interested in all these articles, and then they would just show up on your device. Why did this happen? But yeah, only the person who owns that private key could create those facts with the right signatures, so that your device then runs that authorization rule and says, no, I didn't author these, or yes, I actually did, and then it's able to grab those articles. So yeah, that's a fun one, and that's actually kind of taking the local first idea to even maybe the next level. I have heard on the podcast, the Local First FM podcast, people talking about peer-to-peer, and it seems to be not a requirement for local first, but really adjacent. So yeah, I'm interested to hear how this works out.
Certainly, it's going to take me a long time to give you any sort of real world implementations, but I'm definitely curious as well. And there's two separate projects that I'm kind of working on. The first one is like a personal knowledge application, and that one you might not necessarily be sharing with people, but if you do, because it's your personal knowledge base, you would have only like facts that you've shared with people with the appropriate authentication rules. Obviously,
Yeah.
that one's not so much of an issue. But then the other one is much more like what we've been talking about with this decentralized like base, where you don't have to sign up with anybody. You can keep it offline and connect over Bluetooth if you want to,
Mm-hmm.
and it's going to have various functionalities like knowledge organization and event planning or whatever. And so these two separate ideas are kind of driving the way that I'm approaching the Rust implementation of
Yeah.
the immutable architecture.
Yeah. That is cool. Yeah. I haven't put it on the backlog yet, but I should put something in the backlog about a network a network provider that is peer-to-peer. So yeah, Bluetooth or I don't think that Apple's AirDrop. I don't think that's something that you could really hook into to do this. Maybe you could. Maybe you could say, okay, I'm going to AirDrop to you the Delta, and then you just merge it in.
X.jpg.
Yeah. Yeah. Interesting. I certainly do have plans to take that content address storage idea and, if not make it a built-in part of Janaga, make it a sister project that that if you're using Janaga, you can use this, and they're going to really work well together. I have demonstrated building content address storage on the channel, so there's a video where I just do it from zero, and it's not hard, but it would be better to just have a have a NuGet package or an npm package, have a Docker image, and it's just there you go.
Boom,
Yeah,
go.
here's the pattern.
That's cool. We are doing something similar at my day job, where we have like an S3 bucket, and we've got the hashes. So if you upload a file twice, it's obviously the same hash, and you don't actually upload it. So it's pretty similar.
Yep, perfect.
I know we're short on time here. I did have one actual additional question based on your demo.
Okay.
I noticed that you had these manufactured type hierarchies. There's like blog.site or site. Anyways, blog.post.title or whatever.
Yeah.
And I'm curious, I'm pretty sure you're using that to identify the fact in like the JSON to associate it with its class, right?
Right.
And I'm curious if the hierarchy itself actually served the purpose.
It is strictly a convention. Yeah, I haven't built any rules around it. I'm thinking about making it a bit stronger. So yeah, also kind of harkening back to the local first idea. One of the things that I really want to enable is an ecosystem of applications that can integrate. For your applications to integrate, let's suppose that I think I've mentioned this example. You're building an event planner application. So I'm going to plan a wedding, plan a party, whatever. I've got a whole bunch of things that I do there. Part of what you need to do is to announce the date and the time and put that onto a website where people can register. So that's only part of your model, but there are other applications where that's all they do, or they are adjacent to that. They do that and then something else. So that idea of here's an event, here's the time, here's the place, you can register. I can see the list of registrations, all that stuff. Show, no show. That subset of the model could be a standard that several different applications adhere to, and if they do, and they both replicators point to some common some common set of replicators in the cloud or wherever they happen to be, then these applications would integrate. You could plan an event, and then it would show up on Eventbrite, and people could hit register, whatever. So in order to express that common subset, we will need to agree upon some fact types and some authorization rules, distribution rules, purge conditions, and then create a little rule pack that says this is what that looks like. So for somebody now to trust that rule pack and install it in their own replicator and use it in their own application, they would need to be able to understand it. So an application developer, it's just a specification written in text and factual. They should be able to parse it and say, yes, I trust this one. But then an end user wouldn't really be able to do that. They would be trusting the developer that installed the rule pack. So when a developer uses a rule pack, perhaps the hierarchy is now no longer a convention, but instead that hierarchy is the way for the runtime and even the replicators to verify that the application conforms to the standard set of rules. So by virtue of the fact that the application uses those facts, then I can say this particular namespace belongs to this organization, and I can look up the rule pack in some repository. Not sure about the details, but maybe use that hierarchy to give it some teeth and be able to establish that trust.
Very cool.
But that is long-term vision. Before we get there, we need to enable application developers to use this technology and to deploy replicators, and then to get them on replicator, or to application developers to do that, have to demonstrate the value. so yeah, I think the first thing that I need to publish is going to be a suite of mobile apps and websites that work together, but just all within one umbrella, but in this way. And I can say, look, not only is this a better developer experience, it's a better user experience, and it's already got this ecosystem idea built in. So let's see.
That's awesome.
All right. Well, yeah. Thanks for joining today. Thank you, Jan. Any final thoughts? Oh, you're muted again. I saw the note. There you are.
I was thinking combining DWS with Wikipedia. What is the result gonna be?
Uh-huh.
No.
Yeah, but I'm sure for DWS we're going to need the content address storage. There are images, even just the images of the buttons. But certainly, as part of the workflow, take a picture of the work that you just completed, so that you can put that into the history. So
I think content address storage is a very nice way of working that you've demonstrated many times in the past.
Mm-hmm.
It's really a clever way of working.
Yeah. Wish I could take credit for it. It's there's a database called the Interplanetary File System. It's just a really cool name for a database, but it's content address storage, peer-to-peer. It's basically a really nice pairing with blockchain, because you don't want to put images on a blockchain. But then they have hashes, and you can look up the content in IPFS. But yep. I won't say use IPFS. I'll say here's something else that goes well with Janaga. All right. Well, thank you all, and I think next week. What is next week?
That's the 19th. That's the the last session before Christmas.
Indeed. So yeah, I will be here then,
Mm.
and then maybe pre-record something for Christmas.
Okay.
Yeah.
Yeah, time flies. It goes very fast.
Indeed.
Okay, then we see each other next week, Thursday.
Indeed. Same time, same place.
Mhm. Okay. Michael Cabbage, see you next week.
See
So
you.